Hi all, I am Shweta Reddy, working as Assistant Professor in the Department of Electronics and Communication Engineering from R.M.K College of Engineering and Technology. In the previous video, we have seen about GSM architecture. So in this video of wireless communication, we are going to cover GSM channels. So now let us see something about GSM channels. And to start with our discussion of GSM channels, I will take the very basic components of the GSM architecture. And there are four components, and we very well know that these are the two interfaces. That means that the mobile station and base station is interfaced with wireless access, and rest of the part is an wired communication, and this rest of the part which is connected in wired communication, and this is what we call it as the backbone networks. And in wireless communication subject, I am very much interested to discuss, or I am very much interested to focus only on particular section, on this particular section of wireless communication. That is, this is where this wireless communication exists, and rest of the part will be connected by the wired communication. So when a mobile station is getting interfaced with the base station wirelessly, then there are certain standards which are actually defined how this channels has to be, or which has to be interfaces the mobile station and the base station. And that standard is specified by a common air interface that is called CAI standard. So what is CAI standard? The CAI standard will say that this entire channels, that is let us assume that this is the total channel bandwidth which is available at the base station. So this channel bandwidth has to be divided into two halves, whereas the first half is responsible for transmitting my voice and data, and the second half is responsible for exchanging the control information. So the first set of channels, which is called as voice and data channel, and the second set of channel is called as control channel. And now furthermore, that this voice and data channel is furthermore classified into two halves, whereas the first one we call it as forward voice channel, and the second one we call it as reverse voice channel. And similarly, the control channel is also further classified into two halves, as forward control channel and reverse control channel. So the necessity for dividing the channel into four halves like this is what each and every channel will carry the traffic from one direction to other direction, whereas my forward voice channel is responsible for transmitting the signal from base station to mobile station. So this channel, that is forward voice channel, is responsible for taking the information from base station to mobile station, and whereas similarly the reverse voice channel is responsible for taking the information from mobile station to base station, just opposite. So these two channels will act together so as to make my channel as a full duplex. So what do you mean by full duplex? So what do you mean by full duplex? That is, I can able to transmit my message in both the directions simultaneously. So making the channel full duplex is possible only by combining two simplex channels. And here the forward voice channel is like one simplex channel, and it will carry the signal from base station to mobile station. And the reverse voice channel is again another simplex channel which will carry the information from mobile station to base station. So these two simplex channels will be combined together so as to make my channel a full duplex channel. And the rest of these two channels, that is forward control channel and the reverse control channel, will combinedly work up in setting up the calls. So these channels are especially used for exchanging of control messages or control signals, which is responsible for establishing a call and to terminate a call, as well as establishing a call as well as to terminating a call. So this is what about GSM channel. I hope this is clear. So next comes the channel access mechanisms. So how do I actually access this particular channel and in real time scenarios is, we know that a particular base station should be able to serve many number of mobile stations which is located in that particular geographical area. So there are two primary questions which we have to answer, and our further discussion will be primarily focusing on answering these two questions. So in real time scenario, a single base station will have to serve several mobile stations simultaneously. So how is this even possible? And there are two questions which has to be addressed. The first question is how full duplexing is achieved, which means we all know that the link that is existing between the base station and mobile station is a full duplex link. So how is that full duplexing link is achieved, and what is the technology or principle behind achieving that full duplex link? So that is the very first question I have to address. And the second question is we will try to see how these multiple users are sharing the channel bandwidth, which is available with the base station. So these are the two questions we will be trying to address. So first of all, going with the first question, how is this full duplexing achieved? Normally, full duplexing can be achieved by a technology called duplexing or a technique called duplexing. And when we talk about duplexing, we have two types of duplexing. First one is frequency division duplexing, which is abbreviated as FDD. And as per our concepts, this FDD or frequency division duplexing, we can see that the forward channel and the reverse channel are separated here the reverse channel is a simplex channel, and the forward channel is again another simplex channel. And whereas these two channels are separated with a frequency, which means I'll be allocating a separate frequency to act as the reverse channel, and also I will be allocating different set of frequencies to act as a forward channel. So these are the two channels which will be separated with the frequency. So that is what we actually call it as frequency division duplexing. So one frequency is used to communicate in one direction, and the other frequency is in used to communicate in opposite direction. So combining these two things will tend to appear like a full duplex channel. So this is one method of achieving the full duplexing. And in duplexing, there is one more type which we call it as time division duplexing. So I can achieve this full duplex by TDD, that is time division duplexing as well. So as per our concept, this time division duplexing, the forward channel and the reverse channel will be separated with respect to time, which means the reverse channel and the forward channel will use same frequency but at different time periods. So in time division duplexing, the duplex communication link where the uplink is separated from downlink by an allocation of different time slots. So for an example, if 5 megahertz of bandwidth is allocated, and then this 5 megahertz of bandwidth will be treated as uplink, that is forward channel for a particular time slot, and again this 5 megahertz of bandwidth will be used by the reverse channel, that is by downlink channel for the next time slot. So here the channel will be used as for both forward channel and as well as the reverse channel, but with different time slots. So that is, we actually call it as time division duplexing. And this is the conceptual representation of FDD, that is frequency division duplexing, where you can see each and every channel is divided with respect to frequency. So I'll allot, that is blue represents the different frequency set and yellow represents different frequency set, and then this actually represents the time division duplexing, or you can see that the entire frequency is used for forward channel over a particular period of time, and then the entire frequency is used as the reverse channel over a particular period of time, and then this forward and reverse channel will be happening on a cyclic fashion. So this concept exactly depicts the time division duplexing and frequency division duplexing. So this addresses our first question. So this is how we will be able to see that the available channels in two halves. One can be named as forward channel, and the second one is named as reverse channel. So this division of channels can be done by the concept of duplexing. So either I can use FDD, that is frequency division duplexing, or TDD, that is time division duplexing, to achieve the channel access mechanism. Now this multiple access techniques is further divided into four, which is nothing but FDMA, frequency division multiple access, TDMA, time division multiple access, spread spectrum multiple access, and SDMA, space division multiple access. The spread spectrum multiple access is further divided into FHMA, that is frequency hopped multiple access, CDMA, that is code division multiple access, and hybrid spread spectrum technique. We will see detailedly in the next coming videos. Thank you all.